Welcome to the Geomag world, the original construction system based purely on magnetic fastening that enables you to create daring and spectacular structures. The Geomag magnetic world has two fundamental elements, both very simple: a nickel-plated steel sphere and a plastic rod with two powerful permanent magnets at the ends and a steel plug in the middle. Let's see how it works. Place a sphere near an end, and the sphere is attracted. The same thing happens on the other end. Here's the first model you can attach other rods and spheres to. There are two fundamental conditions to build increasingly more complex shapes. The first is to attain the maximum magnetic force, which leads to the maximum static solidity. The second is to attain the maximum dynamism. The secret of Geomag power lies in two fundamental conditions. The first condition is attained by properly orienting the rods towards the spheres. Both the north and the south pole must rest on each sphere so that the polarities are in series. This way, the well-known law of magnetism is respected. Like poles repel and opposite poles attract. Let's try to demonstrate this with a triangle. Take a sphere and place it near the other spheres. One of the three may be attracted. This means that the spheres, by induction, have transformed into magnets. This is an unbalanced magnetic flow. Magnetism is not at the greatest power. To balance it, detach one or more rods and reattach them, inverting the polarity. Now the sphere will no longer be attracted by the others. Magnetic force is the strongest obtainable. By exploiting this rule, you can build increasingly more complex, fun, and resistant figures. Let's start with a basic triangle with two rods each side and continue by inserting a one-rod triangle inside as reinforcement. We go on to make a sphere formed by 20 triangular surfaces. The sphere is built starting from a pentagon reinforced in the middle and adding on each of its sides triangular shapes until closing the figure with another pentagon above. We've just seen the first condition of the maximum magnetic power obtained with a balanced magnetic flow. We'll now see how to build dynamic forms in motion obtainable with an unbalanced magnetic flow. Let's start with a simple shape like this pyramid. Join a sphere and a rod to the top sphere. The force of attraction will make it possible to lift the figure and make it revolve on its axis. Let's try another simple construction like this hexahedron. Make it revolve as we did before with the pyramid. While it rotates, rest it on a flat surface. By turning the wrist, you increase its rotation and finally detach it from the sphere. A magnetic spinning top that you can pick up and set down. The revolving figure keeps its balance due to the gyroscope effect. Let's see some other demonstrations. The magical swaying effect, also known as repulsion between spheres. Let's take two rows formed by 6 rods with polarities in series. Insert a sphere after 2 rods on both, Then insert a second sphere, moving the two outer rods around. Insert the last sphere and join the two triangles so that the monopolar spheres of the same polarity repel each other. We thus obtain a suggestive swaying motion created by the push downward owing to the weight of the upper triangle and the upward push owing to magnetic propulsion. Another effect is the ballet dancer, also called principle of energy conservation. Let's build this simple figure with the top sphere and the bottom sphere monopolar, capable of attracting other spheres. Let's try to hold it up and make it revolve. This motion recalls that of the ballet dancer. The last example of dynamism is given by the principle of centrifugal and inertial force between monopolar spheres. The spheres on top of this polyhedron are monopolar. Rotating it slowly, we note that the two lower rods buckle as rotational speed increases. This is due to centrifugal force. But that's not all. Let's make the figure revolve again. When rotation increases, abruptly block the hexahedron and the two rods will continue to revolve, driven by the force of inertia. Give it a try. And finally, here are the panels. Brilliantly colored, transparent geometric shapes that snap into place, multiplying plane possibilities and making Geomag even more versatile and creative. The panels give greater stability and increase the resistance of figures. A simple square can easily buckle. If we apply a square panel, though, the entire figure becomes more stable and compact. The panels also offer greater playing possibilities. They in fact optimize the use of Geomag elements. With panels, the same figure can be created using a smaller number of spheres and rods. This sphere, for example, can be made with 120 rods. But with panels, it only takes 60. With the same number of rods and spheres, panels produce shapes of greater dimensions. The panels also have a hole in the middle that makes using the rods and spheres more versatile. You can build solid and compact models with a double lattice structure. Make dynamic and static models with unusual shapes and exciting colors. Rest spheres on the holes in panels and lock them into place with rods below. Move the spheres on the panels with a nice dragging effect created by the magnetic rod below. Now it's up to you to unleash your imagination in building always different figures.